Hey everybody, this is TJ with today's ShopBot training. We've all had that part that hasn't been held properly when we went to cut it, whether it left a shattered edge or it moved. Uh, Tabs or bridges, as they're also known as, are a way to help control that parts are held in place as they're machined. So what we're going to look at today, looking at our Vectric software that comes with our ShopBot and showing some screenshots of cutting out on our ShopBot, we're going to look at several different things with tabs here. First of all, what are the tabs? How to add them, locations of where to add them, and that has a key with the cutting. Also has to deal with you cleaning up afterwards, cleaning up tabs in spots that are easier to get to. So the sizes, the locations, and the cleanups, all these tabs that we're going to look into so you get the highest quality edge finish while holding down your part. So here we can see a small part that's being held down to the table, but to keep the part held to the scrap piece, the tabs have been added. So what we'll look at next in the Vectric software is the location of the tabs and the size of the tabs and the amount of the tabs that were used. Alright, before we get into setting up specific details, let's look at tabs and what they are, where to even access them. So I kind of drew a little simulated version of looking down at your spindle. There's your cutter or your router, and here's your bit. And you have the option of setting up a 3D or a 2D tab. So to even access where you would do a tab is in the profile toolpath. So when you're cutting around an object like this apple here, to do the actual cutout, tabs can be added to closed vectors. So I would select the vector that I'm going to add. I come in and I would set up my profile. I set it up to the material that I'm using. So I'll put the thickness of my material in. I would set up the bit that I'm going to cut it out with, and I'd go through all this. And down here, I would just, when I normally would hit calculate, and it would calculate this red apple, I noticed that there is the cutout. And when I click on this, there is that apple. Well, being able to double click and get rid of the material like that shows that if it can't hold the scrap material here in the preview image, it's not going to hold it out on the machine because there is no hold down built into your tool path. So this is an example if you had a vacuum hold down or were using some sort of a two-sided tape or jig or whatever it might be that you're using that's holding this down, that's great. But today's training is showing you where we would need to add the tab. And adding the tab to this smaller project is what we're going to go through back in our profile toolpath and setting up this tab for this project and for other projects that you may have down the road. Alright, let's start with a fresh version of the apple here. So to add our tabs, we would go into the profile toolpath, select the vector it is that we want to add the tabs to. It keeps the settings in here from the previous time of using the software. So in this case, it has all the parameters and bits that we need selected. If yours isn't looking exactly like this, what I have here is this shown advanced toolpath options, because a lot of times when we're working on these projects, I'll use tabs, leads, ramps, and these other things are stuff that could be saved for other tutorials done by both Vectric and ourselves. Some of you may not have this clicked where you don't have the advanced, and so you may just see this here where it has the add toolpath tab. So whether you're using the non-advanced or the advanced, the tab toolpath functions is going to work the exact same way. So I will go ahead and say if I'm going to add the tabs, I will click add tabs, and this walkthrough here sizing the tabs and placing the tabs. So again, this is depending on the material size, is the size of the tab that you want. You want the tab to be large enough that it holds the part from moving or vibrating to cause chatter on the edge quality, but you don't want the tab so big that it's taking you as the end user a lot of post cleanup, whether you're using a chisel or a knife or a handsaw if your tab size gets that large. So for something like this, we're in a 1/2 inch piece of plywood with a 1/4 inch bit. Again, this is a personal preference after cutting a lot, but a 0.4 in length and a 0.23 in thickness with a 3D tab is a good tab size. Very conservative size, still has a little bit of cleanup afterwards, but a good tab size that I know is going to keep it from holding. The difference between a 2D or a 3D tab is simulated up here in this drawing, where a 3D tab is what you see exactly in the picture in the software over here. It creates a pointed little pyramid shaped tab, where a 2D tab, when this is deselected, is more of a box shape. So a 2D tab has more meat on the bone, if you want to say. It's a lot beefier tab than the 3D tab. The 3D tab is nice because it's a lot faster to cut. When the machine is going along making its profile pass, machine just has to ramp up and ramp down in the Z and continue on going. Where when you have the 2D tab, you actually have the machine stopping, pulling up, stopping, and going over, again stopping, going down before it finally finishes. So you can leave a little bit more of an edge from the machining on a 2D tab. However, then a 2D tab is again bulkier and gives you a better hold down. So on parts like aluminum and plastic where you want to have a meatier tab, sometimes the 2D. So we'll talk about this towards the end of the tutorial, the different tab sizes and shapes for the material that you're cutting. But for our 1/2 inch plywood here for our little apple, I'm going to go ahead again with the 3D tab. If you were to hit calculate right now, it's going to give you a warning message that you haven't actually added the tabs. You've created them, you've made the size, but you need to still click on the edit tab function where you can go in and place the tabs. So I will do that next. One thing before we go into edit tabs is I just want to reference this little green square down here. This square is the start point of the cut. When you're in node editing, if I hit N to go into node editing for this vector, all these little individual nodes, and you're able to right click and make your start point wherever it is that you want. Some people like to start their start point so it's going, say, with the grain of the material, so when their bit plunges in that it works. And some people also, when they set up their tabs here, would like their start point to match with one of their tabs. That's just a hold down preference by some of our ShopBotters. So I move my start point over to here, and when I go into edit tabs, I can also say first tab to match start point. So in this option here, you can give the tab the amount of tabs that you want. You can give a distance between. Right here, looking underneath the tab entry, you can see how to add individual tabs by clicking where you want them, or deselecting them by hovering over them and clicking and they go away, or you have just the delete all. So if I just use what comes in here, hit add tabs, notice that it did put a tab at the start point, and that's something that some users would like to have. As great as tabs are, these bridges, because they will hold this apple, the finished part, to the scrap piece. And a small part like this, they will hold it during the cut, which keeps it from rotating or twisting or moving up and down, chattering the edge quality. However, as great as the tab feature is, just by saying constant number 4 and starting at this point, each vector has a different shape and size to it. So sometimes it will put tabs in places that are not the most appropriate for a post cleanup, meaning you with your chisel or knife or however it is that you're going to clean up the edge. So I'm going to go ahead and leave these tabs right here so you can see what this looks like in the preview mode, because whatever it looks like in the preview mode is what you're going to see out on your machine. And now one apple, sure, you might be able to get around going in there and sanding out the tab, but what if you had 100 of these apples because you were doing plaques for all of your favorite teachers? So let's look at what that would be. So let me hit close and hit calculate, and this pops us into the preview mode, and I will go ahead and hit preview all toolpaths, and this is where we can see our tabs. And we can see the first tab here at the start point. We can see that it ramps up and ramps down because it was a 3D tab. But what I was trying to point out there in the 2D view is these tabs down on these inside corners are not in the most convenient spots for you or me to clean up afterwards, down inside of these internal corners. So let's look at moving back to that toolpath and relocating the tabs into more convenient spots. To edit this, a lot of people make the mistake of coming in and just starting another one. What you need to do is just double click on the one that you've already created. That's going to bring up this toolpath that's already been created, and when you click edit tabs, it will switch back to 2D view and allow you to come back in. For an example like this, I'm going to hit delete all tabs. This is a small project. It's less than 12 by 12 in size. It's not too small of a part where I need to tab multiple sides. So I'm going to go ahead and just do two sides, one and then one right across from it approximately. I'm eyeballing that, and that way I know that that will keep that part from rotating or moving, having two parts in there. Some users like to use just one tab, and they will actually put that at the start point, and they'll just use a one tab along here and then have that along the start point, and that one tab will be all they need to clean up. Again, it's personal preference. You can get on the ShopBot forums and you can read about what people are doing. For personal preference here, from what I've always cut and had success with, I like to put two tabs across from each other with the provided size that I've given you. But for this new tab location and size to stick, we actually need to hit close and hit recalculate here. And it's not going to show up in the preview until you hit reset and then preview your visible toolpath. So I did have to recalculate the toolpath and then recalculate the preview to show the new tab locations. So this was just to walk you through a basic adding tabs to a project. What we'll look at the rest of this tutorial are different options for setting up tabs, sizes, locations, 2D, 3D, using the start point method, different things like that. But if you're going to need to add tabs, it's in your profile toolpath. It needs to be on a closed vector, and this is where your options would be for setting your tab size and your tab locations by going into edit. But no matter what you change here, just make sure you hit calculate and always preview it in 3D to make sure the tabs are physically there and then also in the position that you told them to be. Another quick helpful resource if you really want to read more about terminology and you're just getting into this, if you go to help and help contents, it's going to bring up Vectric's user manual that goes with this. And as you scroll down through, you'll see when it gets into talking about profile toolpaths, there's all about tabs here. Tabs, tab sizes, how to add them, everything we just showed at in the video format. And it goes into a little bit more depth with pictures showing you your 2D and your 3D tabs. So feel free to check out the user manual that comes with the software as well. Alright, for this next section, we're going to look at several projects out there, and we're going to find do's and don'ts for these. We're going to also see tab sizes, tab locations, and just some things that you can use based off real projects to help setting up the tabbing of your parts. So here's the first one we look at. It's an adjusted lamp. I might point out that all of these projects are available from our website, shopbottools.com. And just look on the right hand side of the screen there and you'll see something called Ready to Go Projects, and that's where you can find all these. So let's look at the drawing file for this, and if we were to go over and look at the profile of the large parts, you can see that these tabs were on there. Just like the earlier Apple example, we had 3D tabs, 0.4 and 0.22. Under the edit objects here, this was set up as 8 per tab. Now that was, if I went and looked at these, you could see where these tabs were just used here as add tabs, and these were actually strategically put in places. You got to think about, as this part is cutting, where tabs may be necessary. So the software isn't going to think about the part for you like vibrating of a long part, like this long end of the lamp. So having a tab along the length of it and on the ends of that will help keep that part in a position that's not going to vibrate or chatter. So a lot of these parts you'll see in the next few projects are actually put in there in specific spots from cutting. So unless you have experience where you've cutting and seeing these, that's where it's nice to watch this tutorial and see some of these projects. So when you have a long cut like this, it's nice to have a tab along the length of it and on the ends of it to keep that from moving. So that's where you see the tabs along that piece on here. the profile of the small parts is a little bit different. Since these were smaller parts, wanting to hold these in place, we actually put more tabs in there. So as you see, profile small parts and profile large parts, they were actually separated not just for the tab purposes, but also for feeds and speeds as far as the bits. So you could have different tab settings. Maybe these smaller parts, after cutting these, you realize 4 tabs was overdoing it. So I could go back in here and take away 2 of these tabs. So some of your parts still have the 4 tabs, where some have the 2. So you don't need to have separate tool paths for different tab amounts. You can have 2 tabs, 4 tabs. Each part can be its own. Again, I would hit calculate for that to take in place, but the reason for the small parts and the large parts, again, had nothing to do with the tabs in this example, but it actually had to do with the bits, feed, and speed. And this next one here is a puzzle. This is cut out of red oak. So this is a piece of wood with grain, and showing you that, you can see that the tabs were put in a place that goes with the grain. And the reason for that is it's a lot easier to nip out a tab at the end with a utility knife or a chisel when the tab is put with the grain. If I was to have moved these tabs to the end, it would be a lot harder to nip out of there. So that's where the tabs on this red oak were put to go with the grain. And the last thing that we'll see at the end of all these examples is cleaning up your tabs. The next one we look at is the actual giant combination lock. So like a padlock you'd have on your school locker in high school. This is a wooden giant version, and it's just to show the mechanics of how it works on the inside. So looking at this from the Vectric software, this part has a lot going on, and it's a lot of little parts and a lot of narrow skinny parts that are all nested together in a half a sheet of material. So if I was to go over here and look at the profile of all outer parts, you can see that there's a lot of different tabs going on. Now again, this is an example where these tabs were actually made a little bit larger because they were specific for the job. Yes, it's still half-inch plywood. That goes back to the earlier example of the apple, but having a lot less scrap material in between these skinnier, smaller parts went with a beefier tab to get more strength in between these. So if we look at these here, you can also see that tabs were put in areas where the material would be thinner, and I'll show you that in the 3D preview. Again, I'm just showing our cut depth that we're going all the way through, and to preview all the tool paths. So you can see this is a pretty complicated, pretty intense file. If I look through here and I zoom around and see, there are a lot of spots where these parts come closer to each other. So tabs were also added into places where this through cut would have had just a small piece through here. So even a place like this, I took the hold down screw head that was normally right here out of this part for this video, because if this hold down was in place, you can see that the hold down there will end up being a drywall screw in all those locations, where the tab that's holding your good part is being held to the scrap piece, and the screws are holding the scrap piece to your ShopBot spoil board. Well, over here in an example where there is no hold down, what we will see here is without these tabs, this part would have a very good chance of becoming loose and moving around. And even with tabs, it's a small part that's left in there. This is so narrow along here that this isn't going to matter. This is actually just going to end up being a thin piece or even sawdust. But right here, this would be an example where you'd probably want to have a hold down, or you'd want to have 1, 2, at least 3 tabs in that part to keep that little scrap piece from moving around. So if you look at this part that's on our website, you'll see where tabs have been added in extra because this part was nested. Ideally, what would happen for if this was a project to be cut again and again was find a larger piece instead of trying to fit it into a 48 by 48. Put this into a larger piece so you don't have to over tab it. Over tabbing it is what has been done in this example of having extra tabs to hold it in place to keep it from being loose and holding it to the scrap material, which is going to cause more work for the end user as a post cleanup after the cut. So again, just pointing this out as another project example. This next is cutting into HDPE plastic, and we'll look at the video cutting before we see the file. So we're cutting into 1/4 inch, and you can see right there it lifts up and goes down, and there's your tab. And also along the back here, I'll show it to you what it looks like with the tab exposed on the end, so we can see the 2D tab. Now the 2D tab is used here in the HDPE, and also used in aluminum a lot because it's more of a structural tab. It might take a little longer to cut as far as picking up and dropping back down, the starting and the stopping of the ramp speeds of the machine, but it has more of a square base and more strength when it comes to the tab. So we'll look at the file here where we saw the first one and the third one cut on the profile of these. And if you look over here, this was an example from a project that was showing different types of cutting that the ShopBot can do, showing that the tabs were placed opposing each other, and this had the 3D tab not checked, and it had a 0.1 by 0.1. So this was more of a square tab, and it was what would be used more into plastics and also used in aluminum and non-ferrous metal cutting. Again, it's just a stronger tab. It's not 3D, so it doesn't cut as fast as far as the ramping. And we'll end at the very end with the different cleanups as well. A project like these jigsaw puzzles have very small, intricate parts, so you don't want to have your pieces moving or chattering while you're trying to cut them. So with all the inside and outside corners, if you don't place your tabs in an area that's easy to clean up, you're going to create yourself a lot of work post-cutting. So here's looking at the jigsaw puzzle. If I double click on profile, you can see that the tabs went in here to edit tabs, and instead of using the add tab feature, they were put in places that I know would have been easily to clean up. So that's where you're going to see that your tabs are. And also from the 2D view, if I turn on the profile here, I can actually zoom in and you can see the width of this tab, which is showing you exactly the tab size that you set. So on the duck head, I put a tab on the inside just for an example to show you. That's how big that 0.4 length is. So by, again, turning on the profile right here, I can see that is 0.4. And that's a big tab, even though it's just a small t by what the software shows you. The software is also showing you the physical size of that 0.4. So is that a good place for you to want a tab? Do you have a way to get in there and clean that up? Would it have made more sense to edit these tabs? I can click on it. It turns from the check mark to an X and deletes that, and refigure that out. Or if I put a tab here and here, does that make more sense? Well, again, as far as cleanup purposes, I don't have to try to get a tab down in here. But how well is your cleanup? You've now placed a tab into an area in a jigsaw puzzle that is a pretty intricate spot. Are you able to clean that up precisely as the machine cut it? So again, think about your woodworking techniques, your shop, and your setup, and where you would put tabs. Personally, for me, I would move my tabs to here and here where they are shown on the screen, because I can come in here and clean this up with a spindle sander and just barely touch that surface, which wouldn't leave a mark. You're already going to have a slight tolerance when it comes to these parts to get them to fit together. And again, at the end, I'll show you some pictures of different ways of cleaning these up. Next, we'll look at the patio chair, which is cut out of 3/4 inch plywood. This chair all goes together with mortise and tenon joinery. And by looking at the Vectric file here, we switch over to the toolpath side, and we have our hold down and our pockets. But if I click on the profiling of the parts, you can see that these tabs were placed in a way that make a lot of sense as far as cleaning up, cutting purposes, and strength while cutting. All the tabs on the slats here are lined up in a vertical manner, and the reason for that is you get into a project. Let me calculate this and show you the preview of this. When you get into a project like this where you have cut away so much material, and without these tabs actually being in between the slats of this chair, the pressure of the big 3/8 cutter that's cutting on this will push and move your material back and forth, which again is going to knock it out of being the 2" by 20" precise cut that you want. So if you cut away enough material in a project like this, that whatever is left for scrap will flex back and forth. So for us to fit 2 of these out of a 4x8 sheet, they had to be put together this close. So you do see a scrap clearance in here, but the tabs being all vertical, lining up with each other, they actually work for strength and structure of this part and allow that part to cut and not have any vibration or moving in there. So the tabs serve a purpose of not only holding the part to the scrap material, but they also help, in this case, adding strength to the material that's being cut away. And just to point out, no matter where you add the tab or the number of tabs, they do need to be cleaned up. Whether you use a chisel or a knife, it is going to be something that you want to cut out, because if you physically just push them out, you're going to rip the veneer. So they do need to be cut out. A lot of times a tab is easy to be cleaned up with just a 1/4" round over bit on a router. So if you're going to round your parts over anyways, you only need to remove the tab enough to get it so when it slides across the router bit, it'll actually round itself, clean the edge up, give it its round over, and remove the tab. And then a lot of people also will put stuff on disc sanders or spindle sanders, and that is a way to take the tab and clean it off the edge. We've looked into the world of tabs or bridges today, whatever you want to refer to them as, how to add them, the different sizes of them, locations, where to look out for putting them as far as how it's going to affect your cut, whether it's a cleanup process that you're going to have to deal with, taking away the strength of the scrap material, the ease of cutting them out afterwards. Think about the post cleanup that you're going to have to do when using the tabs. So thank you for joining us for today's training. Remember, ShopBotTools.com is a great place for resources. You'll find other tutorials, documents, user forum. So thank you for joining us today, and we will see you next time.